Kumusta? And good day, everyone. Now, I'm going to share a new content in my channel which are topics related to trigonometry. Now, before discussing a topic on angles, no, so let us consider the definition of trigonometry. So, the term trigonometry is derived from two Greek words. We have trigonon, which means triangle, and metria means measure. That is why this uh, this is a branch, or trigonometry is a branch of mathematics that deals on the study of triangles, their parts like sides and angles. Now for angles, this is a union of two rays having a common endpoint called vertex. Now in our figure, we can see here an angle theta. So, if this is formed as a rotation, so it starts with an initial side. So, these are the two rays mentioned in the definition of angle, and they intersect on a common point B, where B is known as the vertex of our angle. We have the initial side, and if that's rotated, so it coincides with the terminal side, so the amount of rotation is the angle theta. Now, other Greek letters commonly used in denoting an angle are alpha. We also have beta, we also have gamma, and theta. Now, angle can be expressed or can be written in a standard position. When can we say that the angle is in standard position? Now, in the xy plane, so if we have an initial side of our angle that rests on the positive x-axis starting from the origin as its vertex, then this is the angle formed, which is an angle in standard position. In this case, we have an angle that is formed by counterclockwise rotation. By the way, pwede sa mo produce og angle in a clockwise rotation from the initial side, so like that. Now, there is a sign convention considering that the angle can be formed in both counterclockwise or clockwise direction. Angle formed by clockwise rotation are positive angle, and we also have the negative angle for angle which is in a clockwise rotation. Now, we have different units in the measure of angle. So, we have a unit in degree, and by symbol, we have this as the symbol for degree. Now, if one complete rotation is considered, then that complete rotation will be subdivided into 360 equal parts, and one division of which is actually 1 degree. So 1 degree is 1 over 368th part of a complete rotation, and 1 degree can also be subdivided into 60 division called minutes. So 1 degree is 60 minutes, and by symbol we have this 60 minutes, so we have a prime symbol. Now 3,600, when that is in seconds. And we have also a symbol 3,600 seconds, so we have double prime for 1 degree. So 1 degree is 3,600 seconds. 1 minute can be subdivided into 60 equal parts, and 1 division is termed as seconds. So 1 minute is 60 seconds. Now another unit is radian. So a radian measure, or 1 radian measure of the angle, can be formed if we have an angle having a vertex at the center of the circle and forms an intercepted arc which is equal to the radius of the circle. The central angle formed there is 1 radian. So here is a figure showing an angle which is in 1 radian value. So if this is the radius of our circle, this is our intercepted arc, and if this measures also takes the same value as r, so if the intercepted arc is equal to r, then the angle formed here is what we call as 1 radian. Now, in a unit circle or a circle having a unit radius, the intercepted arc is equal to the central angle theta. Usually, the central angle theta is expressed in radian, so S can also be in radian. However, our intercepted arc will also take the same unit as the radius r. So, theta is in radian. Okay? Another unit is radian. In this case, so you have to imagine that the complete rotation is subdivided into 400 equal parts. So 1 radian is 1 division of width, so which is equal to 1 over 400 part of a complete rotation. Mils is also a unit in an angle, which is used in armed forces. So subdivide a complete rotation into 6,400 equal parts, and 1 mil is 1 division of width, so 1 over 6,400 part of a complete rotation is mils. Okay? Now, to convert an angle expressed in a unit to other units, then simply recall these equivalent values in 1 revolution. 1 revolution in degree is 360, and radian that's 2 pi, and radian that's 400, and mils that is 6,400 mils. Now, unit, if not indicated, it is understood that the value of the angle is expressed in a unit of radian. So, that means, if the angle is expressed in degree, radians, and mils, so all these units must be clearly indicated into your value. Because without the value, or without the units associated with the value, then that value can be misunderstood being an angle that is in radian. And that can make your answer wrong. So, for conversion, we have some problem. If we have 2 over 7 of a revolution and we have to give the answer in degree, then that is to be converted so using a conversion factor based on 1 complete revolution. Because this is revolution, so my denominator will be expressed in the same unit of revolution. My numerator will be expressed in terms of degree, so that the unit produced will also be as indicated. So we have 102.857 degree. If this is in decimal, that means this is an approximate value because it is associated with rounding up of digits. Now, let us show in letter B a value which is exact. So, 2 over 7 revolution, and we multiply that with a conversion factor. It is radian that is needed. So, 1 revolution is 2 pi if that is in radian. So, revolution is out. We have 4 over 7 pi radian. So, this is in fractional form. So, there is no rounding up of digits made because this is not expressed in decimal. So, this is what we call as exact value. Now, letter C. So, we have to change the unit to radians. So, if this is revolution, and we need to have a radian unit, then 1 revolution is 400 radians. That's equal to 800 over 7 radians. Letter D. So, we have 2 over 7 revolution. My conversion factor is 6,400 mils. So, we have 1 revolution, and that's equal to, if you multiply, that is 1,828.571 mils approximately. To practice more on the conversion of units, so we have a value of the angle or a measure of the angle which is expressed in degree and decimal form, and this will be converted also to radian, also in approximate value or decimal form. 81.633 to radian. My conversion factor is to consider 1 complete rotation. In degree, so unit in degree will be placed in the denominator side of my conversion factor, and I have 2 pi radian in the numerator side. This will give us a value which is 1.425. Now, usually, problem dealing with degree to radians and radians to degree, our conversion factor is not actually based on 1 complete rotation. It may be based on half of a rotation because if this is a fraction, we notice that there is a common factor of 2 which can be removed. That is why if this is reduced to lowest term, so it would also be possible to have a conversion factor which is pi radian is to 180 degrees from degree to radian. If that is from radian to degrees, it should be 180 degrees is to pi radian. So, multiplying them will produce also the same result. So, next time you can encounter a problem like this, so you may convert or you may use a conversion factor which is not based on 1 complete rotation but based on half of a rotation. So, you will produce the same answer here. So, an angle in degree minute seconds is required to be converted in degree in decimal. So, Actually, as if we have three terms of different units, so unit must be expressed in degree in order that all the terms can be added. Okay? So 33 degrees, I take it as a separate term. Then the 25 minutes will be converted also to degree. We have a conversion factor. 1 degree is to 60 minutes. This is out minutes, so this is already in degree. So 47 seconds can also be converted to degree. Using conversion factor, 1 degree is to 3,600 seconds. So by adding them being in a homogeneous unit of a degree, so there I arrive with a value which is 33.430 degrees as my answer. Now in the fourth, so this is the opposite because the angle is given in degree in decimal and we have to give our answer in degree minutes seconds. Now, you have to separate the integer value in the angle which is given, which is 34. You separate that one. Now, the decimal value of 0.12341 degree will be converted to minutes. You multiply them, so you will arrive with a value which is composed of a unit of degree and seconds. Now, add unit of degree and minutes. Now, in a minute value, there is also an integer part which is 7 and there's also a value which is in decimal. So try to separate integers like 34 degrees, 7 minutes, and the decimal in minute will be further converted to seconds. So 1 minute is 60 seconds. Multiplying them, we arrive with this as the result. Okay? Then what's next? So most of us are familiar with the use of our calculator and we know that degree in decimal can be converted to degree minute seconds or degree minute seconds to degree in decimal. So, how to use our calculator if number 3 will be converted using our calculator to degree in decimal. So, first, you have to look on your calculator and check if the function in degree minute seconds is present. Now, if that's present, then you can put your calculator on and key in the given. So, 33, press the function. Then, 25, click the same function. Then, 47 with the same function. When you press equals, then on the display, it will display the angle as indicated in the given. So, that will appear. Correct? Then, you can click again the degree, minute, second functions and your calculator will display an answer which is degree in decimal. Now, it's indicated to have our answer in 3 decimal places so you can round this up. So that's why we have 33.430 degrees. If in case it is the angle in decimal in a degree, be converted to degree minute seconds. So if this is still found in the display of your calculator, so you can simply click the function degree minute seconds to convert to degree minute seconds. Just in case wala, so you can key in the value and then press, no? So you can have this, you can click this to this function and then that will automatically convert to degree minute seconds value of your